Alright, in this problem, we are looking at 121 different properties, and they were randomly divided into two groups, okay? We have two groups. We have the experimental group, and we have the control group. And in the experimental group, there were a total of 79 properties, and in the control group, there were a total of 42 properties. So I'm going to call the control group N2 and the experimental group N1. The mean of the experimental group, so that's my x bar of group 1, was 3.2, and the mean of the control group, x bar of group 2, was 5.1. The standard deviation S of group 1 is 4.1, and the standard deviation of group 2 is 6.3. And based on this, we want to see if the letter from the police was effective in reducing the number of crimes at the 5% level, okay? So that's their experimental group. So basically we're asking, is the experimental group, is the crime rate lower, experimental group, lower than the control group? Okay, and so we see that the number is 3.2, x bar for the experimental group is 3.2, and the mean of the control group is 5.1. So it seems like it's lower, but we want to see if it truly is lower or not. So our null hypothesis is that the means of the two groups, mean 1 and mu 2, are the same, and the alternative is that the groups are not equal. I'm sorry, we want to know if the experimental group is lower. So mu 1 is less than mu 2, okay? And sometimes, for the purpose of our analysis, we're going to set mu 1 minus mu 2. We're going to say, if they're equal, then that means the difference between them is 0. Or, if mu 1 is smaller than mu 2, then the difference between them should be negative. It should be less than 0. That's what we're going to be asking. So in this case, our test statistic is what we observed minus what the null hypothesis states divided by our standard error. So our observed difference, what is the observed difference? Well, what we saw was group 1 had a mean of 3.2, and group 2 had a mean of 5.1. So the difference between them is 3.2 minus 5.1. That gives me a difference of negative 1.9. So my observed difference is negative 1.9. Is that significantly different from 0, which is what's stated in the null hypothesis? On the bottom, I put the standard error. So the standard error is just kind of this ugly formula that we can't do a whole lot about, is s1 squared over n1 plus s2 squared over n2. So this is the square root of s1, 4.1 squared over n1, which is 79, and 6.3 squared over n2, which is 42. Okay, so when you punch this into the calculator, what you end up getting is this entire thing, after you take the square root, is 1.076. Okay? And so I'm going to do negative 1.9 divided by that number, and I get a t statistic of 1.766. And so here I'm going to look in my t table to see if it's significant or not. So the degrees of freedom that I'm going to use is going to be the size of my smaller sample, which was 42, minus 1. So it's going to be n minus 1 for the smaller sample. So I'm going to have 41 degrees of freedom, and I have to round down. So I'm going to round down to 40 degrees of freedom because that's the only one that shows up in the table. And so at 40 degrees of freedom, I'm looking for the number 1.076, and I'm sorry, 1.766 at 40 degrees of freedom. And so at 40 degrees of freedom, the numbers that I see 1.684, and that corresponds to tail probability of 0.05. And then I see 2.021, and that corresponds to a tail probability of 0.025. And so I see that 1.766 fits between these two numbers, which means my tail probability will be in between those two numbers. And because this is a one-tailed test, okay, it's one tail because the alternative has only a less than sign, so it's one tail. So my tail probability is my p-value. So my p-value here is going to be less than 0.05, but greater than 0.025. So that's my tail probability there. And based on this, I can then answer the question, what does this mean? Okay. So I'm going to just erase this out so I have a little bit of space to write. So this means that because if I use the p-value, if my alpha is 5%, I see that my p-value is less than alpha. So that means I reject the null hypothesis. And that means we have evidence that the experimental group, meaning the ones that received the letter, had a lower crime rate than the control group. Okay, so again, please make sure you understand all of the steps setting up the null and alternative hypothesis, figuring out the standard error, which, so all of these steps, nothing in of themselves are very complicated, but it's just a lot of pieces to put together, and just remember the process of going through all of this.